I'm Ishita Jain doing PhD from IIT Kanpur. So as we all know that time is money and the clock is ticking very fast. Each of us is trying to go ahead of others, whether it's jobs or the traffic. Bigger fishes are eating smaller fishes, signifying wars around the world. As a result, we are trying to enhance our dimensions by inventing more advanced technologies. It is not far away when we will be flying to our offices by flying cars. We are also building advanced aircrafts and electrical vehicles. So the advancements in aviation industry and the electric vehicles are one of the fastest growing sources of greenhouse emissions that is driving the global climate change. So is there any way by which we can actually decrease these emissions and increase our sustainability? Yes, there is, and that is a field in which my lab is working on. Let me demonstrate you by a very simple paper airplane. So when I throw this airplane in the sky, this airplane will travel in the space as long as the thrust provided by me is not overcome by the gravity. So where the problem has occurred? So the plane has experienced the drag which is significantly higher than the lift. So what can be the solution for this? If we actually cut down the drag, I can travel this paper airplane to a larger distance at low energy input, and that is my motivation. So my motivation is to reduce the drag on the airfoil shapes, and where you can locate these airfoil shapes, that is on the aircraft wings and the gas turbine engines. So interestingly, what we are trying to achieve today has been happening easily around us in the nature. For example, many aquatic animals can move in the water at very high speed with low energy input. For example, sharks. The shark has a skin which actually reduces the drag by themselves by 5 to 10%. And how does this even possible? Because their skin has a small tooth-like denticles on it. That is called dermadenticles, which helps them to reduce the drag. And what is the mechanism behind it? It just can be explained very easily. We can demonstrate that here easily by these two figures. So this is the first figure which shows the smooth wall which is having no denticles. And this is the second figure which has 3 denticles on this. And the direction of the denticle is aligned with the flow of the water. I have named the direction in parallel to the denticle as X, vertical to the denticles as Y, and the transfer to denticles as Z. So the unstable flow has created these circular motions when the shark is moving in the water. Because of the presence of these denticles, these circulated flows are not able to transverse in the Z direction, and this is why the drag on the skin of the shark has been reduced. From this point on, the research has been involved further in this direction to reduce the drag by exploring different types of roughnesses and their arrangements. So we have also explored a different arrangement of the shark denticles that are placed transferred to the flow direction, and we have got a beautiful result that has reduced the drag by 20 to 30%. So motivated by this, as a futuristic plan, we are also going to explore the herringbone rivulets, which is inspired by the birds. Thank you for your attention.